let me begin with a word of prayer. So get up here. Here we go. Heavenly Father, we thank you for this day. I thank you again for this class. Just pray that we'd guide our steps today. Help us just to learn more about how to solve radical equations, and that we just all also learn more as we review with the quiz, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
So we'll do the quiz at the end, all right? Towards the end, anyway. So I'm going to start with some examples from section 1.6 on radical equations. So let's get straight into it.
Can you please hand me a pen?
A pen. I don't know if I have one, Michael, but I'm sure somebody has one here.
I got you, bro. I got an extra.
Okay.
There you go.
Okay.
You're welcome.
Thanks, guys. Yeah, all I got is markers. And a,
You're very practical for writing on paper.
yeah.
Yeah, I have like 5 minutes.
Okay, guys, so the order of business here today, to start with, is solving equations involving radicals, all right? So we worked a couple of these at the end of last class, but we need more practice. So here we go. To start with, we'll start with a relatively easy one. We'll start with the square root of 2x minus x plus 4 is equal to 0. All right, this is number 52 from the textbook, for what it's worth. All right, so what should we do? Like, the first thing to do is to isolate the radical. So we've got square root of 2x is equal to x minus 4. So isolate the radical by adding things, subtracting things as necessary. And then we square it. So square both sides, right? And when we square the left-hand side, we simply get 2x. We square the right-hand side. Pay close attention to this. You need to multiply it out. All right? About 40% of the class always makes the mistake, it's just x squared plus 16 here. But that's not all there is. There's also
Minus 8.
minus 8x in the middle.
Okay.
Very good. So you just have to FOIL it out, right? Think about multiplying. This is what? This means x minus 4 times x minus 4, right? So when you multiply that out, you get all that. Now what do we have? Well, we've got a quadratic equation. So let's put everything on one side. Maybe we can factor it. I don't know. So I've got x squared minus 10x plus 16 is equal to 0. Can you guys solve that?
Oh.
X minus 2
Whoops.
and x minus 8. I think that works. Very good. So what are my solutions then? And I should say potential solutions because we'll need to check on whether or not they're actually honest to goodness solutions. So it looks like either x is equal to 2 or x is equal to 8, right? Now, let me just point out that we can already kind of tell, well, I guess we can't tell yet. So like, I like to look at the original problem as the square root of 2x equals to x minus 4. It's nice to try to use that to check your answers. See, because I can try it out, right? Is the square root of 2 times 2, is it equal to 2 minus 4? What do you think? Well, that's the square root of 4, which is 2. Is 2 equal to 2 minus 4? No, that's 2 equals to minus 2, which is, that's false, right? So this right here is an extraneous solution. Of course, you could plug the number back into the original equation if you prefer, right? So like square root of 2 times 8 minus 8 plus 4. How's that work out? I'm going to switch it up a bit here. Let me plug the 2 into the original equation as well. Square root of 2 times 2 minus 2 plus 4, which would have been equal to
Square root of
4. So anyway, extraneous for the 2 doesn't work if we plug it back into the original equation. The 8, we get what? Square root of 16, which is
4.
so we get 4 minus 8 plus 4, also known as
0.
0. So hooray, that is an honest-to-goodness solution. Yep.
So if we have a question to ask for the solutions, so we don't include extraneous not included?
The extraneous is not part of the solution, right? I boxed the solution, the other one's not. Yep.
I have a question. So given x, y is greater than 0, find the values of c, a, and b for which cx to the a, y to the b equals the square root of 25xy cubed over 3 square root of 8x squared.
Oh yeah, I'm not doing that one right now, Michael. We worked that one last time, so that one. But we can come back to that. But
We worked that one we did last time?
yeah, we did a problem like that last time. That's like problem 42, right? Is that 42?
Oh, whoops.
Yeah.
Sorry.
It's okay. I mean, I can come back to that. I'm trying to do these today at the moment. But
Maybe I should look back at my notebook first.
next class, I'll try to start one with one of those, okay?
Sorry.
It's okay. So, do you guys, question, why is it that we get 2 solutions here? Do you understand what's happening? Why is it that happens? What is this 2 actually the solution of?
The top one.
The top one? Well, kind of. If we take this one, right, and instead we wrote minus the square root of 2x equals x minus 4, right? If we try plugging 2 into that equation, does it work? See, is minus the square root of 2 times 2 equals to 2 minus 4? Is that true? Well, this is the square, this is the square root of 4, which is minus 2.
-2. They are
Right.
equal.
So what's the difference? Like, you notice that this equation I just wrote up here, right? If we square this equation, we also get to here, right? You square this, it also gets right here. So what's happening is whenever we square an equation, we're basically losing track of which the positive and the minus, right? Like plus or minus the square root of stuff equal to other things. When you square that, you lose track of the minus, which is why we're getting this extra solution. It's actually the solution to an associated but different problem where instead of having plus the square root, you have minus the square root. That's why we get this pair of solutions. So, all right, let's work on another problem. Example 2. Excuse me.
Square.
Here's a little bit trickier one. We've got square root of x minus the square root of x minus 12 equals to 2. How are we going to solve a problem like this? This is, by the way, number 54 in the homework.
But there's no 54.
Well, I know, Michael, but I do problems in the section whether or not they're recommended. But you can do the recommended ones. So again, the starting idea is to isolate a radical, right? Now you got choices. Do you want to isolate the x minus 12 or do you want to isolate the x? I think we should isolate the uglier one as a rule of thumb.
The second one.
So yeah, if we isolate that, we have the square root of x minus 12, right, is equal to the square root of x minus 2. Does everybody see how I did that? So I moved it to the other side, I subtracted 2 to the other side, and then I flipped the sides. Make sure we're on the same page here. Now, I square both sides. All right, so squaring x minus 12 squared gives me x minus 12. This, I get the square root of x squared minus 4 times the square root of x plus 4. Now let me clean that up a bit. We're looking at x minus 12 is equal to x minus 4 times the square root of x plus 4. So now what?
Oh.
Does anything simplify? I agree, Michael. Let's see here. So this and this, these,
Cancel out.
right? So we cancel those. And I'm going to put this to the other side. I get 4 times the square root of x equals to what? 4 plus 12, also known as 16. Right? And then I suggest we divide the equation by 4, since there's a common 4 on both sides. Does that seem reasonable?
Yep.
So we get square root of x is equal to 16 over 4, which is 4. We have now isolated the radical, and one more step. What do?
Square root.
Square it. Square both sides, right. So this gives us x equals to 16. Now, I sure hope this isn't extraneous. If this is extraneous, then we're out of luck, right? It doesn't have to be a solution to the original problem. Whenever you square a problem, you might actually be solving a different problem in the end. So if I plug it back in, does it work? Is the square root of 16 minus the square root of 16 minus 12, what's that? We've got 4 minus the square root of 4, 4 minus 2. So we plug it back in, and it works. Hooray! All right, let me see if I can find us another problem. So there's a bunch of these in the homework which are kind of like this. If there's two so basically to summarize what just happened, if you have two radicals like this, what you're going to have to do is isolate one of them, square it, and then isolate the other one and square it again. So it takes two squarings to get rid of two radicals. Yes, Michael?
Never mind.
Okay, glad to help. Let's see here. So this one is a little bit easier.
So how did you get square x minus 12? Oh.
How did I get square x?
Where you subtract 2 on the other side and then add the square of x minus 12 to the other side.
Right. Yeah, I mean, to go from here, the next step I made was just the square root of the square root of x minus 2 is equal to the square root of x minus 12. And then I just took those and flipped the sides to get it. All right, so this one is number 63. Yeah, the square root of the square root. But actually, this one's easier than the one we just worked. Right? So how do you solve this? Well, yeah, square it, right? So square both sides. Square both sides. And that gives us 2 times the square root of 7x plus 2 is equal to 3x plus 2. Okay. Now what? We still got a square, still have square root, right? So what we can square it again, right? But then you got to multiply out the 3x plus 2 times 3x plus 2, right? So be careful when you do that. What do we get? So we square both sides, right? Now be careful. When we square 2 times the square root, what happens? It turns into a 4, that's right. So what we're going to get is we're going to get 4 times 7x plus 2 is equal to 9x squared plus 12x plus 4. But we should distribute the 4, right? This gives us 28x plus 8 is 9x squared plus 12x plus 4. Now we should put all of our variables on one side, like it's a quadratic equation, right? So this is going to give us 9x squared. What's 12 minus 28? 16. So minus 16x minus 4 equals to 0. I mean, does it factor? It's a book problem, so odds of it factoring are pretty high, right? But how do you factor this thing? I think it's like a 9 and I think it's a 9x and an x. Because in order to get that 16 in the middle, I need a pretty big number. So like 9 times 2 is 18. And 18 minus 2 is 16. So I think it's like a 2, and a 1, and a 9. So like I need a 2 and a 2, right? That gets me the 4. I need one of these to be positive and one of these to be negative. I want a minus 16. So I put a minus over here, right?
Negative.
And a plus over there. And I think that'll do it. I get 9x squared. I get plus 2x. I get minus 18x. I get minus 4. There we go. So what are my solutions? Potential solutions. Yes, Michael?
The solutions are x equals negative 2 over 9 and x equals 2.
X equals negative 2 over 9 or x equals to 2. All right. Now do those work?
We'll have to check.
We'll have to check. All right. And that was a minus. You said minus 2 over 9. I forgot to put the minus up there. Well, that's unpleasant.
I love when fractions.
Well, I think it's the same thing.
What's that?
I think we'll just use the square root of the other one.
Let's see here. Are either one, what's that? Well, let me start with the 2. That one's easier, right? So we've got 2 times the square root of 7 times 2, which is 14 plus 2, right? So that is the square root of 2 times, the square root of 16 is 4. So we got the square root of 8 from the left hand side of that. The right hand side, we've got the square root of 3 times 2 plus 2, also known as the square root of 8. All right, so definitely 2 is a solution. It works when we plug it back in. Minus 2/9, I really don't want to check, but I will. All right, so we have the square root of 2 times the square root of 7 times minus 2 over 9 plus 2. All right, so that is the square root of 2 times the square root of minus 14 plus 18 over 9. Well, at least it's positive. That's a good sign. Now that's the square root of 4 over 9. What's the square root of 4 over 9?
2
over
3.
3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. So we have the square root of 4 over 3. All right, that's what I got from plugging it in to the left-hand side of that equation. How about the right-hand side? I regret doing this problem. This does not have the kind of easiness I prefer for an in-class example. But anyway, it's good for us. Let's finish it. So we need to plug the other potential solution into the right-hand side. How's it go? It should be easier, right? What is the square root of 3x plus 2? I'm putting x equals to minus 2/9 to try to check if it works. So 3 times minus 2 over 9 plus 2, which is the square root of minus 6 plus 18 over 9, which is, of course, the square root of 12 over 9, which is
4 over 3.
Yeah, exactly. So apparently, they both work. Woohoo! So there you go. And I think if we thought harder about the problem, we'd realize that they both had to be solutions. But anyway, that's okay. Any questions before I go on?
Let me take a photo of these just in case.
Go for it, Michael. While you're doing that, oh, okay. I'll move the camera while you're doing that. How about that?
Got it.
All right. Let's move on here. So we can also have problems that involve cube roots or even fourth roots, right? But the principle of how you solve those kinds of problems pretty much the same thing. All right, so like, for example, if we're looking at the fourth root of x minus 15 equals to 2, the fourth root of x minus 15 equals to 2, how would we solve such a problem? How do you get rid of the fourth root? What do you do? Yep.
I think you...
So, how about this, guys? The square root of x equals to, like, whatever, let's say 7. This is really x 1/2 equals to 7, right? And the reason that we square it is because when you square this equation,
Oh, so x squared.
that gives us x to the 1 is equal to 49, right? So if I have this, this really means x minus 15 to the 1/4 power, all right? So if you want to get rid of the if you want to get rid of the 1/4 power, we simply raise both sides of the equation to the by the fourth power. So like this. And so we get x minus 15 equals 2 times 2 times 2 times 2. What's 2 to the fourth? It's what? It's in fact 16. And so what our answer is simply x equals 31. So at first glance, this problem looks a little scarier than the other ones we just worked, but actually it's much easier, right?
Professor?
You're welcome, Michael. So let's look at some more of these. Example 5. Here we go. Suppose you're up against x minus 3 to the 2/5 power is equal to 4x to the 1/5 power. Man, it's sounding really rowdy over in the other room. I don't know what's going on over there.
So we need to reverse the process.
Reverse the process. So what do you guys think? How would you suggest we achieve Michael's goal of reversing the process? How would we do that?
So we know equals is 1 over 5.
Yep.
So
Multiply the powers, see. We had a problem at the end of last class where I just I raised both sides of the equation by the reciprocal power. But I've got different fractions, so that doesn't quite work. But that's the right kind of idea. We want to get rid of the fractions, right? So what power will get rid of all the fractions here? The 5th, right. So what you want to do is just raise both sides to the 5th power. All right? That to the 5th power, and that's something you can do. You can take an equation and raise both sides to the same power. This is like an allowed operation on equations. And that's a good thing to do because then the 5's cancel. See, because 2/5 times 5 is just equal to 2. And 1/5 times 5 is just equal to 1, right? And so what that gives me is x minus 3 squared, which is annoying, but not too bad, is equal to, well, 4x. And that we can solve that all day long, right? Not a problem. That's a quadratic. Seems like all roads lead to quadratic equations, right? So this is what, x squared minus 6x plus 9 equals to 4x. Put all your x's on one side. Hey, Michael, we solved this one earlier today.
yes, we did.
So how do you solve that? I'll let you guys look at it. Do my erasing over here. So can you guys factor it?
Yes, I can.
And what is it? It's x what? X
Minus 9 times x minus 1.
All right. And my solutions then are
X, 9 and 1.
x equals to 1 or x equals to 9. Are they actual solutions?
We'll see.
We'll see. All right. So we have 1 minus 3 to the 2/5. Is that equal to, question mark, 4 times 2, excuse me, 4 times 1 to the 1/5. So in other words, I've got minus 2 squared to the 1/5, which is equal to 4. I'll get out of the way here a second, Michael. Yes, it checks. Okay, you can plug it in. So definitely the x equals 1 works. If I plug it in both sides, I get 4 to the 1/5. Let me explain to you guys what I just did. When I'm faced with the 2/5 power, the way to think about that, or one way to think about it at least, is if I have stuff to the 2/5, I can think about that as stuff squared all to the 1/5 power. That's one way you can do it. Alternatively, and usually much less usefully, you could also think about it as stuff to the 1/5 power squared, right? You can go either way. It kind of depends on what you're simplifying, which move is useful, all right? But anyway, long story short, this checks that as a solution. And if we try plugging 9 in, we're going to have 6 to the 2/5 power, right? Is 6 to the 2/5 power equal to 36 to the 1/5 power? Because if I put 4 times 9 is 36, right? Are those equal? They are, right? Because if I take 6, I square it, I get 36. So in fact, these are both 36 to the 1/5 power. So yeah, it checks. Listen, you can also use your calculator to check, right? Your calculator does fractional powers. You can just check it as a decimal on both sides, see if they match, right? You could do that. So that solves, I think that shows you almost every problem type in section 1.6. If I missed one, I'll circle back to it. But I think I'll let you guys have the rest of the time, well, almost for the rest of the time for the quiz. I'm going to jump in and stop you about 5 minutes before the end of the class. So you'll have about 10 minutes to work on this quiz, and then we'll talk about its solution. Okay, guys?
Okay.
I will not collect the quiz. All right? But I will find a way to figure out which one of you is here. So as soon as you can get it, you can start working on it.
Thanks.
Where's Holly gone to? Rats.